All right, so we're going through this right here, writing in the RCos form. So this question says, f of x is equal to cos x plus root 3 sine x. And we're supposed to write it in the RCos form. So this is f of x. So if this is your f of x and you want to write it in the RCos form, first you need to find out is what is your r and your alpha, where r is greater than 0 and alpha is in your first quadrant between 0 and pi by 2. So first thing you just have to remember the formula that r is equal to a squared plus b squared all square rooted. So r is equal to the square root of a squared plus b squared. And in this case, remember your a is the coefficient of cosine x. So a is 1. So r is going to be the square root of 1 squared plus your b is your root 3. And then it's going to be root 3 squared. And so 1 square plus root 3 square is 4. And then we're square rooting 4, and so r equal 2. So now we get r equal 2. Now that is r. Now next thing is alpha. How do you find alpha? Alpha is equal to tan inverse of b over a. Remember, b is the coefficient of x. So alpha is equal to tan inverse your b, which is root 3 over a. Your a is 1. So that's going to be alpha. And so alpha is tan inverse of root 3. And you have to make sure your calculator is in radians so you can find tan inverse of root 3. And you're going to get pi by 3. This is pi by 3. So now that we know that this is alpha, then we're good. So now we can express f of x in the RCos form. So now let's write our answer. And so now we can write that f of x is going to be equal to r is 2, and so r is 2, so it is 2 cos x minus alpha. So f of x can also be written as 2 cos x minus alpha, where alpha is pi by 3. Alpha is pi by 3. Pi over 3. So that's part 1, soft, capital T. This one is done and dusted, soft. But that's it. This is part 1. Nice. The next part now says to find the maximum and the minimum value of cos x plus root 3 sine x. In other words, find the maximum value of f of x. Always remember the maximum value is r. So the maximum, so this is part 2. And we know that the maximum value of f of x, that's going to be equal to r. But what was r? R was 2. Then what is the minimum value? The minimum value of f of x is equal to minus r, and so that is going to be negative 2. That is the minimum value. So the maximum value is 2, and the minimum value is -2. Next thing it wants us to do is find the value of x for which the minimum occur. In order to find the value of x for which the minimum occur when f of x equal -2. That's when the minimum occur. So what you're going to do is set f of x equal to -2 and solve for x. That will give you the value of x for which the minimum occurs. Set f of x equal to its minimum value. So we're going to set f of x equal, this is f of x by the way, so we set, so that is 2 cos in bracket x minus pi by 3. So 2 cos x minus pi by 3, we set that equal to -2. And so solving this, as we can see, we divide 2 from both sides. And so what we're going to be solving is the cos of x minus pi by 3. Solving the cos of x minus pi by 3 equal to -1. That's what we're going to be solving for the minimum value. The cos of x minus pi by 3 equal to -1. So let's go ahead and solve that. So of course, if we're solving the cos of x minus pi by 3 equal -1, first thing you have to do is you draw your circle. We know that is what we do. We draw our circle. Where is cos negative? Cos is negative in the second and the third quadrant. So we're going to find cos inverse, not of -1, but find cos inverse of 1. When you find cos inverse of 1, you are going to get 0. You get 0. And so that means that the angle, that implies that since we get 0, that means x minus pi by 3 is going to be equal to, because when we find cos inverse, this is what we get left back with. So x minus pi by 3 is going to be equal to, angle in your second quadrant is pi minus your angle in the first quadrant. So x minus pi by 3 is going to be equal to pi. Now, angle in the third quadrant is pi plus 0. So we don't need to put any or. It's just x minus pi by 3 equal pi. So now we make x the subject, and making x the subject, we bring over this pi by 3, bring over pi by 3 to get x is equal to pi plus pi by 3, pi plus pi by 3, and so x work out to be, that is 4 pi by 3. So this is the value of x for which the minimum occur, 4 pi by 3, soft. So that's the value of x for which the minimum occur. So we can just write that down here. So the value of x for the minimum, for which the minimum occur, the value of x for which minimum occurs is, that is 4 pi by 3, 4 pi over 3. That's the value of x for which the minimum occur, 4 pi by 3. Beautiful, nice, soft. Now we need to find the value of x for which the maximum occur. To find the value of x for which the maximum occur, we have to solve f of x equal to the maximum. F of x equal maximum was f of x equal 2. That's when f of x is maximum. So what we're pretty much solving again is we're solving 2 times the cos of x minus pi by 3 equal to 2, and we're solving for x. That will give us the value of x for which the maximum occur. So of course the 2's cancel each other. And so what we're going to be solving now is the cosine of x minus pi by 3 equal to 1. Quite rightly so, when we're solving this equal to 1, you draw your circle. Where is cos positive? cos is positive here, and cos is positive here. So we find cos inverse of 1. When you find cos inverse of 1, you're going to get 0. And so that means that implies that x minus pi by 3 equal 0. That's one possibility. Or x minus pi by 3 equal to 2 pi. Now we know that this solution won't be valid. How do I know that it is 2 pi? Remember, it is, if this is 0, angle in the fourth quadrant is 2 pi minus your angle in the first quadrant. This one won't be valid because they say x is between 0 and 2 pi. This one is not valid because x must be between 0 and 2 pi. And so we can forget about this side over here, because if you work this out, you're going to get x is bigger than 2 pi. So we focus on over here. And so x equal pi by 3. So when x is pi by 3, that is when you're going to get f of x equal to when x is pi by 3. So this is the value of x for which the maximum occur. So we can go ahead and write that down. That the value of x for which the maximum occur, don't have no space here. So let's write it beside it. The value of x for which the maximum occur, right here, x is pi by 3. That's when the maximum occur. Maximum occur when x is pi by 3. Nice. Of course, we can go ahead and test our solutions. We can definitely test our solutions. So let's go ahead and test our solution. So right here, we're just going to sketch the function. So we're going to go to graph. We're going to go to plot the function. And the function that was given was cos x plus root 3 sine x. So we're just going to plot it. We're going to plot f of x equal to cos of x plus the square root of 3. So we can write it as 3 raised to the half power. That's root 3 sine x. All right, how can I get in root 3 now? Cos x plus root 3 sine x. Really want to get that root 3 there. All right, this should about do it. Yes, so there we finally get it. So this is cos x plus root 3 sine x. Here's the graph. As we can clearly see, the maximum values are these y values. These y values are the maximum values. So if I were to draw a line across, these are all the maximum y values. So clearly we can see that the maximum y value is 2, right? The maximum y value is 2, and we're concentrating between 0 and 2 pi. 2 pi, remember pi is 3.14, so 2 pi is somewhere 6 point something, somewhere about. So we're concentrating between here and here. We're concentrating roughly between these regions, right? We're focusing inside here. Since we're focusing inside here, we can see this is the maximum value. This is the max, which is R. So R is indeed 2. And see the minimum down here, the minimum is minus 2, minus R, just like our solution. Now remember, we also said, what did we say? Looking back at our question, we also said that it is 2 cos x minus pi by 3. And so we show that the maximum is 2 and the minimum is 2 by sketching this graph. Now you probably want to show, how do I know that the value of x for which the maximum occur was? The maximum occur when x is pi by 3. Always remember, pi by 3, we know that pi by 3 is, here is this, pi by 3, if we're to calculate pi over 3, it is roughly 1.04. That's pi by 3, 1.04 roughly, all right? So look at this now. The value of x for which a maximum occur is right here. Let's see what that x value is. So show coordinates. See it here? X coordinate is roughly 1.01, and I didn't put it at the right spot. Need to put it down by the right spot. Because R is actually 2. I need to put A at the right spot. This looks like a better one for A. Maximum points, show the coordinates. Here it is, 1.032, right? And pi by 3 is roughly 1.04. So it shows you that indeed the x coordinate for which the maximum occur between 0 and 2 pi, remember we're focusing on between 0 and 2 pi. So as we can see, we're focusing on right here. The only part we're focusing on is between, if I were to put like a border, we're focusing primarily between here, between 0 and 2 pi, we're focusing in this region. All right, and as we can clearly see in this region right here, the maximum is right here, so, and the maximum occurs when x is 1.03. Now, where does the minimum occur? The minimum occur right here. Minimum occur right here. Let me put a point right there. So this is where the minimum occur, right here. That's where the minimum occur. Now let's see the x coordinate for this. -4.20, -2. That's the x coordinate. That's when the minimum occur. Remember, we said the minimum occur at 4 pi by 3. This was the x value we said the minimum occur, 4 pi by 3. Now what is 4 pi by 3? That's 4 times 3.14 divided by 3, which is the same 4.2. 4 pi by 3 is 4.2. So it's dead stamp correct. This is the x coordinate for which the minimum occur. Nice. And this is the x coordinate for which the maximum occur. So we can see that our calculations are correct. And the maximum is indeed 2, and the minimum on the graph is -2. So we know that all our calculations are correct. Nice. So that is that question. Easy, soft. Let's look at a more intimidating question. All right, this question says express f of x, which is cos x minus sine x in the r cos x plus alpha form. Express it in that form. So first thing, we have to remember that r is going to be equal to the square root of a squared plus b squared. That is r. R is the square root of a squared plus b squared. And so then what do we know? A is 1, b is 1. So that means r is the square root of 1 square plus 1 square. And 1 square plus 1 square is 2. So r is the square root of 2. Now that we know that r is the square root of 2, we're good. Now we just need to find alpha. Now alpha is going to be equal to tan inverse of b over a. So alpha is tan inverse of b, which is 1 over 1. Tan inverse of 1 over 1 is pi by 4. That is pi by 4. Tan inverse of 1 is pi by 4. So we can rewrite f of x now and say that f of x is actually now just equal to r is root 2. So f of x is equal to root 2 times the cos of x plus alpha. So it's root 2 times the cosine of in bracket x plus alpha, where alpha is pi by 4. So it's root 2 in bracket the cosine of x plus pi by 4. That's what we have. This is what we have, and we're done. We're nice, soft. That is f of x in that form. So that's part 1. Now, what did they also ask us to do? They asked us to, we need to find the maximum and the minimum value of f of 5 over f of x plus 2. Now, this one is a little bit different. Now, always remember that every cos function or every sine function is going to be between r and minus r. So this is how we do this question. We start by saying f of x is less than or equal to r and greater than or equal to minus r. This is where the function will range between r and minus r. Those are all the possible y values. So since those are all the possible y values, then since this is where f of x is between, then what if we were to add 2 to it? If we were to add 2 to it, then what we could definitely say now is that means by adding 2 to all sides, f of x is going to be between, f of x plus 2 that is going to be between, add 2 to both sides. By adding 2 to both sides, it's going to be r, which is root 2. So f of x is going to be between root 2 plus 2 and minus root 2 plus 2. Minus root 2 plus 2. Nice. This is where f of x is in between. Now, the next thing we want to do is take the reciprocal. We're going to have to take the reciprocal. So by taking the reciprocal, we're going to get now that 1 over f of x plus 2. So 1 over f of x plus 2 is going to be between, this is where they're going to be between 1 over f of x plus 2 is going to be between, when you take the reciprocal, you flip the sign, so it's going to be 1 over, instead of writing minus root 2 plus 2, I will write 2 minus root 2, and then instead of writing root 2 plus 2, I will write 1 over 2 plus root 2. It just looks easier this way. Then now, remember what the question wanted. It wanted 5 over f of x plus 2. So now you're going to multiply each side by 5 to get 5 over f of x plus 2. 5 over f of x plus 2. And it's going to be less than or equal to 5 over 2 minus root 2. So this is now 5 over 2 minus root 2. And it's greater than or equal to 5 over 2 plus root 2. That's where f of x is in between. Nice. Now, some persons like to put it in decimal. If you like to put it in decimal, that's fine. All right, so we're out of space, so we go around to the whites. So we have 5 over f of x plus 2, and we said that it is less than or equal to 5 over 2 minus root 2. It's less than or equal to 5 over 2 minus root 2. And we also said that it is greater than or equal to 5 over 2 plus root 2. 5 over 2 plus root 2. That is that. This is what we have. And so in reality, if you're to put this as a decimal, 2 minus root 2, and then 5 divided by that, in reality that is 8.53. So in reality, this part works out to be 8.53. Let's write that a little bit better. We know right here is really 8.53. So we can say that 8.53 is greater than or equal to 5 over f of x plus 2. And then it is actually greater than or equal to 2 plus root 2. That's 3.41, and 5 divided by 3.41 is 1.46. And so what we can finally conclude is that this is going to be the maximum. The bigger one is the maximum, and this is the minimum. So we can tell them that the maximum value of 5 over f of x plus 2, the maximum value of 5 over f of x plus 2, we can tell them that that is equal to 8.53. We definitely can tell them that. That's what we can conclude. Nice. All right, so definitely this is what we can say is the maximum value of 5 over f of x plus 2. And then now we can also likewise tell them that the minimum value of 5 over f of x plus 2, we can tell them that this minimum value is 1.46. If you wanted to put it in decimal, if you like to be exact and you like to write it in pretty and neat, you can put those root of things if you want to be neat. But if you just want to give them the answer, that's fine. All right, nice. So this will be the maximum, this will be the minimum. Now, of course, I am always going to show a sketch. And so, of course, we're going to look at the sketch of how this looks. So again, remember, just to point this out one last time, you don't have to write decimals. You can keep your answers exact. It is purely up to you. Now let's look at the sketch now. So we're going to sketch, what was the function again? We're going to sketch that function, cos x minus sine x, and then we're going to sketch 5 over f of x plus 2 and see what that look like. All right, so first we're going to sketch cos x minus sine x and see what that look like. So let's look at that. Go to graph. We want to sketch cos x minus sine x. So we go to rectangular grid is what we're using. We're plotting in the graph of cos x minus sine x. This is the graph of cos x minus sine x, and as we can see, this is the maximum value. These y values are the maximum value. So if I were to put a point right here, that's the maximum value. So let's see maximum value. Just to look at the y coordinate, maximum value is the y value right here. And this y value is 1.41. And that 1.41, I guarantee you that the square root of 2 is 1.41. So that's the maximum y value. All right, so that indeed shows that the maximum value is 1.41, which is root 2. That would be the maximum value for f of x. But we didn't want that. Now, let's look at this part now. We want to show that the maximum and minimum value of 5 over f of x plus 2 is, those maximum value are 8.5 and 1.4. So let's show that now. So we're going to need to plot a new graph. So let's go to a new sketch, new graph. And we need to plot 5 over f of x plus 2. So we need to plot 5 And that's being divided by f of x, where f of x is cos x minus sine x, and then it is plus 2. That's what we're plotting, 5 over f of x plus 2. Here it is, this is how this function behaves. Now, let's show what's the maximum value. The maximum value is up there. What's the y-coordinate up right there? Let's go ahead and find that coordinate right here. These are maximum y values. Let's find the coordinate. All right, so that's the x coordinate. We don't want the x coordinate, we want the y coordinate. So let's go back. Show coordinates. Look at the y value, 8.51, and it's because it's not exactly on the point. Should be exactly on it, that's it. And we can see that the y value is 8.53. That's the maximum value, because if we're to draw a line that's passing through all these points right here, you can see that those are the maximum values. So the maximum value is indeed 8.53, right? That's the maximum value. Now the minimum value would be these y value down here. These would be the minimum values. These would be the minimum value down here. So let's find what's the minimum value. So show coordinate 1.47. Maybe I rounded off wrong. We got 1.46, but this is saying that the minimum value is 1.47. The y coordinate, see there? Minimum value, right? That's because the range of the graph is between here. If we're to shade in between here, just shading the graph, meaning the range, the y values, it range from 1.47. It ranged from 1.47, I'm going to write 1.5 to 8.5. So the maximum is the 8.5 and the minimum is the 1.5. So indeed, our solution right here is true. Indeed, we are correct. Nice. That takes care of this example. Nice. So let's look at another question. This one says express three sine x minus 4 cos x in the form r sine x minus alpha, where r is greater than or equal to 0 and alpha is between 0 and 2 pi, and find the maximum and minimum value of 1 over 1 minus the square root of f of x. No problem at all. So in order to do this now, we have no real issues in doing this. So first thing, we can write that f of x is equal to, f of x is 3 sine x minus 4 cos x, and we want to write it in the form r sine x minus alpha. That's what we want to write it in. So we need to find r and we need to find alpha. How are we going to find r? R is equal to the square root of a squared plus b squared. So r is equal to the square root of a squared, that is going to be 3 squared plus b squared plus 4 squared. So r is equal to 5, because that is 9 and 16 is 25, square root 25 is 5, so that is r. Then we need to find out what is alpha. Alpha is going to be equal to tan inverse of b over a. Alpha is tan inverse of b over a, which is tan inverse 4 over 3. All right, so what is tan inverse of 4 over 3? Tan inverse of 4 over 3 4 over 3. So when I work out tan inverse of 4 over 3, I'm getting 0.927 in radians. 0.927, and that's in radians. RAD, radians. Nice. And so that means we can write now that f of x is equal to r, which is 5 sine x minus alpha. So in bracket, it is 5 sine x minus 0.927. This is f of x, 5 sine x minus 0.927. That is f of x. So since this is f of x now, the next part of the question says, find the maximum and minimum value of f of x. Find the maximum and minimum value of f of x. So we're going to do that now. First thing, we're going to have to start by, remember we said that f of x, any function, is always between r and the minus r. So f of x is always between r and the minus r, right? And in this case, our f of x is going to be between, r was what? R was 5. So it's going to be between positive 5 and negative 5. Now looking at what do we want to show? What do we want to show? We want to find 1 over the square root of 1 minus f of x square rooted. So first thing we're going to have to do to get to that destination is square root f of x. Square root f of x first. That's the first thing. Square root f of x to say that f of x is going to be between the square root of 5 and, well, this one right here, we can't square root a negative number, so this part become invalid. All right, so look at this. This part become invalid. Yeah, man, this part become invalid because we cannot square root negative 5. Can't square root negative 5. So only focusing on this part now. All right, so that means f of x. So we're not focusing on this part anymore. We're not focusing on this part no more. So this is what we have. The square root of f of x is less than or equal to 5. Then we're going to have to take the negative of it. So what we're going to get now is minus the square root of f of x. When you multiply by minus 1, you change the inequality sign. So minus f of x is now greater than or equal to minus root 5. Remember, we throw away this side of the inequality because we cannot square root negative. Well, not yet at least. Cannot square negative. We cannot square a negative in unit 1. So that's why we throw away this side. Just to point that out, we cannot square negative. So we focus on this side to get minus root 5, minus the root of f of x is greater than or equal to minus root 5. Then what do we do next? We had to add 1. So we're going to add 1 to both sides. Adding 1 to both sides, we get 1 minus the root of f of x. We're getting now that this is greater than or equal to, adding 1, we get 1 minus root 5. Yeah, man. That's what we get. Then now we need to reciprocate this by taking 1 over. So taking 1 over this, we get 1 over 1 minus the square root of f of x. So we get 1 over this, 1 over 1 minus the square root of f of x is less than or equal to, that is now 1 over 1 minus root 5. So what can we conclude? If you want to put this in decimal, do so. Feel free to do so. So 1 minus root 5 and 1 divided by that, you get negative 0.81. Negative 0.81. So let's put that in words somewhere right here. So put it in words right here. We're saying that there is no minimum value. There is no minimum value, and the maximum value of maximum value of all of this weird function, maximum value of 1 over 1 minus the square root of f of x is the maximum value is equal to that right there, minus 0.81. That's the maximum value, minus 0.81. Easy, soft. So we can write it right here. There is no minimum value. There is no minimum value. Then we can write the maximum value. The maximum value is minus 0.81.